Since the dawn of humanity, we've looked up at the night sky, filled with thousands of stars, and wondered, is there life out there? Are we the only ones in this vast, mysterious universe? This question has fascinated philosophers, scientists, and dreamers for centuries. Today, we dive deep into one of the greatest mysteries of all. Is there any life outside of Earth? Before we even start looking for life, let's first try to grasp the sheer scale of the universe. The observable universe is approximately 93 billion light-years across, containing over 100 billion galaxies. And each galaxy has millions, if not billions, of stars. Most stars, like our Sun, likely have planets orbiting around them. The numbers are so vast that it's hard for our minds to comprehend. With so many stars and planets, the possibility of life elsewhere seems almost inevitable, doesn't it? Now let's take a moment to think about this scale. Imagine looking up at the sky on a clear night. The stars you see are just a tiny fraction of what's out there. For every star visible to the naked eye, there are millions more beyond our sight. And with every star potentially having its own planets, the chances that some of those planets could host life is a thought that makes the universe feel a bit more familiar. But before we get ahead of ourselves, what does life even mean? For scientists, life is typically defined as something that can grow, reproduce, respond to stimuli, and maintain homeostasis. On Earth, life has taken an incredible diversity of forms. From the tiniest bacteria to the largest whales, life is everywhere. But could life exist in forms we can't even imagine? Could it thrive in conditions that would be hostile to us? Perhaps. In fact, astrobiologists believe that life doesn't have to resemble what we see on Earth at all. We've only just begun to scratch the surface of understanding what life is. Take, for example, extremophiles, organisms on Earth that live in the most extreme environments. These are creatures that thrive in boiling hot springs, near deep-sea hydrothermal vents, and even in environments without oxygen. If life can exist in such harsh conditions on Earth, why shouldn't it be possible in other parts of the universe, where conditions are vastly different from what we're used to? For decades, we've been searching for clues beyond our planet. The search for extraterrestrial life comes in two major forms: looking for microbial life within our own solar system and listening for signals from advanced civilizations elsewhere in the universe. Let's start with our own cosmic neighborhood. Mars, Venus, and the moons of Jupiter and Saturn have long been the focal points of exploration. Mars, in particular, is the most promising candidate for hosting life. Its surface, once warm and wet, may have supported microbial life billions of years ago, and recent discoveries of methane spikes in its atmosphere suggest something is actively creating or releasing gases. Could microbes still exist under its dusty surface today? NASA's Perseverance rover is currently hunting for signs of ancient microbial life. In fact, just a few years ago, the Curiosity rover found evidence of ancient lakes on Mars. But even if we don't find life on Mars, it doesn't mean we're at the end of our search. After all, Mars is just one of many possible habitats within our solar system. Moving beyond Mars, let's turn our attention to some of the moons of Jupiter and Saturn, moons that have become some of the most exciting prospects for life beyond Earth. Europa, one of Jupiter's moons, has a thick ice crust that covers a vast ocean of liquid water. Enceladus, a moon of Saturn, has geysers that shoot water into space. This suggests that, beneath the icy surface, there could be the perfect environment for microbial life to thrive. These moons have the necessary ingredients: water, organic compounds, and energy sources like hydrothermal vents. The idea of life living under an icy shell or in deep, dark oceans isn't so far-fetched. In fact, many scientists are optimistic about the potential for these moons to host life. Europa is particularly interesting. A mission is currently planned to launch in the coming years called the Europa Clipper, which will investigate the moon's icy surface and ocean beneath. The findings could change everything we know about the potential for life in the solar system. Even if life is common in the universe, why haven't we found it yet? This leads us to the famous Fermi paradox. In simple terms, the paradox is this: with so many stars and planets out there, and with billions of years of cosmic history, why haven't we encountered any extraterrestrial civilizations? Some scientists have speculated that intelligent life might be rare, or that civilizations rise and fall before they can communicate across the vast distances of space. Others propose that advanced civilizations might be deliberately avoiding us, or that we simply haven't been looking in the right way. Think about it. Earth is a tiny speck in a universe so vast that the nearest star is over 4 light-years away. Even if civilizations out there are sending signals, it could take centuries for those signals to reach us, or for us to detect them. Some researchers suggest that perhaps civilizations go extinct before they can communicate with others, as technological advancements might bring about self-destruction. Or, what if advanced civilizations simply choose not to make contact? Some have proposed the zoo hypothesis, that extraterrestrial civilizations are aware of us, but intentionally avoid interfering with our development, much like humans might avoid interfering with animals in a zoo. Despite these mysteries, we continue to search. One of humanity's most ambitious efforts to answer this question is SETI, the search for extraterrestrial intelligence. Using radio telescopes, SETI listens for signals from other civilizations. But so far, we've heard nothing definitive. A few potential signals have been detected, but none have been conclusive. But even though we've yet to detect an alien signal, that doesn't mean we're not listening. In fact, our technology is improving every day. With the launch of powerful observatories like the James Webb Space Telescope, we'll be able to examine exoplanets with greater precision, looking for chemical signs of life in their atmospheres, signs like oxygen, methane, or even the infamous techno-signatures that would indicate an advanced civilization. The search for extraterrestrial life has never been more promising, and with future missions to distant moons and exoplanets, the next breakthrough could be just around the corner. On Earth, life thrives in some of the harshest environments imaginable. From volcanic vents on the ocean floor to acidic lakes in Chile's Atacama Desert, life finds a way. These extremophiles survive where conditions would be deadly for most other organisms. This suggests that life might not only exist in the temperate zones we're familiar with, but could also flourish in environments vastly different from what we're used to. Take the deep-sea hydrothermal vents, for instance. These vents spew out hot, mineral-rich fluids that support entire ecosystems, even though there's no sunlight. The organisms living there have adapted to survive without oxygen, living off chemicals in the water instead. This resilience gives scientists hope that life could exist in environments where we once thought it would be impossible. As we push forward into the future, we have more tools than ever to search for alien life. Upcoming missions to places like Europa, Titan, and Enceladus could provide us with the first direct evidence of life beyond Earth. The discovery of even microbial life on another planet or moon would be one of the most profound moments in human history. It would prove that life is not unique to Earth and that we are not alone in the universe. Additionally, the discovery of exoplanets, planets that orbit stars outside our solar system, has exploded in the past few decades. Thousands of these exoplanets have been discovered, and many lie within the so-called habitable zone, the region around a star where liquid water could exist. The search for habitable exoplanets is one of the most exciting frontiers in modern science. Perhaps the search for life isn't just about finding something out there. It's also about understanding who we are and our place in the cosmos. In the grand expanse of the universe, our search for life beyond Earth may be a journey to understand life itself. Are we the product of some cosmic accident, or are we part of something much larger, something connected to the stars? As we venture further into space, we continue to ask, are we alone? And in doing so, we begin to ask deeper questions about our own existence, our future, and the possibility of connecting with others, intelligent or not, on a cosmic scale. So while we may not have the answers today, the search continues. Every new discovery brings us one step closer to unraveling one of humanity's greatest mysteries. Whether or not we ever find life beyond Earth, the pursuit itself has already expanded our understanding of the universe. In the end, the search for life may not only be about finding aliens, but also about discovering more about ourselves.